Hello, I'm Ridae, a master's course of DTM Lab. The paper I'm going to review today is a Convergence Technology Opportunity Discovery from firms based on technology portfolio using the stack denoising autoencoder. The bibliographic information of the paper. The paper was published in the journal IEEE in 2022, and the keywords and highlights of the paper are as follows. The table of contents is the same as the follows. First, I will introduce research background and purpose. The emergence of convergence technologies that generate high added value has spurred active research and investment by both firms and governments aiming to secure future markets. These perspectives emphasize that a firm's unique technology portfolio and skills can serve as sources of competitive advantage if they are rare, inimitable, and non-substitutable. Convergence involves high resource requirements and implementation risks. Existing technology opportunity discovery approaches often overlook firm-specific resources and technology portfolio, so this study proposed a novel convergence TOD framework that reflects individual firms' technological convergence capabilities by analyzing their technology portfolios. To address the limitations of conventional CF methods, the study employs a stack denoising autoencoder, which offers strong performance in handling large and sparse datasets. The purpose framework is validated using real-world data from firms in two high-tech industries, information technology and biotechnology. This chapter is the background of the study. Technology convergence is the process in which technologies from different application fields are integrated and reborn as new technologies. Technology convergence is the source of innovative new technologies and product creation and has been recognized as a key driving force for economic growth. Various strategies and policy studies have been conducted to promote technology convergence at the national and corporate levels, but a technology convergence recommendation framework at the corporate level that considers customized technology convergence capabilities and marketability is needed. Among various data sources, patents are the most used in technology convergence research and are effective in identifying a company's technological capabilities and degree of convergence. So, this study aims to identify a company's convergence capabilities based on a combination of specific codes. TOD is an activity to identify new or promising technology fields with potential for technological advancement and establish a roadmap for monetization from them. Most predict technological opportunities at a macro level and don't specifically reflect individual company situations and technological capabilities. Therefore, this study aims to discover technology convergence opportunities that are suitable and effective for companies by considering both the growth potential and level of competition in the market. Collaborative filtering is a representative method of recommendation systems providing accurate, customized recommendations based on the similarity between customers and products, which contributes to reducing the burden of customer choice and increasing satisfaction. In this study, it intends to utilize an autoencoder that compresses and restores input data into a low-dimensional latent space to extract data features. but traditional autoencoder has a problem of converging to the identify function, which may deteriorate learning performance. Therefore, utilize that learns to add noise to the input and restore clean output to enhance generalization performance denoising autoencoder. The number of combinations of technology used by company is large, data is sparse, and individual companies have capabilities in only some fusion technologies. Therefore, in this study, SDAE-based collaborative filtering is applied to company technology combination data to effectively explore fusion technology opportunities. This study proposes a method to evaluate technology convergence capabilities using a company's patent portfolio and recommended the most suitable technology convergence opportunities for the company based on this. And the steps are as follows. I will explain each step in more detail. First, to develop customized CTOD for companies, it is essential to evaluate the technology convergence capabilities of each company. Since patents are the most widely used indicator representing the overall technological capabilities of a company, this study performs a patent-based technology convergence capability analysis. Instead of individual space technology classification criteria, a company's CTC is derived based on CPC pairs. The frequency of CTC appearing in the patent held by a company is considered as a technology convergence capabilities. For co-patents or applicant are considered to have the corresponding CTC capabilities in consideration of technology spillover during the technology development process. Through this, a CTC-based technology convergence capability vector is constructed for all companies, and the CTC frequency is converted to a 1 to 5 point scale based on fuzzy logic. Through this conversion, a technology convergence preference vector for each company is constructed, which is then used to input the CF model. Stacked denoising autoencoder has the strength of effectively extracting latent factors and restoring sparse input. This method provides a sophisticated prediction score for CTC that company does not have, enabling accurate and reliable technology convergence opportunity recommendations. In addition, it overcomes the limitation of sparse company technology data with deep learning-based restoration capabilities. Not all technology convergence combinations with high LPS as latent preference score derived from SDAE-based CF are promising CTODs for actual companies. Since feasibility must be considered together with the saturation of technology market and the lack of technological capabilities of company, three indicators are utilized for this purpose. And three and the indicators are as follows. The condition for CTS to ultimately become a CTOD suitable for enterprises are high technological growth potential, low technological competition, and a TPI index of 1. These indicators play a critical role in narrowing down SDAE-based recommendations to actionable strategic level technological opportunities. This is an empirical study. IT and BT were selected as a target technology fields, and the two fields are active in technology convergence, making them appropriate verification targets. This paper collected registered patents containing CPC codes related to IT or BT from USPTO patent data. CPC codes are used as subclass. To verify the framework, three companies were selected as targets considering their technical resources and spectrum. The number of collected patents, key patents, and CPC core codes of each companies are as shown in the table below. The proposed sdae-based CF model is verified to have higher recommendation accuracy than the existing CF method. In particular, the ability to overcome data sparsity issues and capture complex inter-company technology convergence relationship is evaluated. The data is divided into training data and test data, and only companies that applied for at least one patent with or more different CPC during the test period are analyzed. As a verification procedure, the technology convergence capabilities of each company are input, and the traditional cosine similarity based CF and the proposed sdae-based CF are compared to calculating that the latent preference for CTS in both methods, and then the error with the actual CTS is measured. As a result, the sdae-based CF shows a lower error rate, proving that the recommendation accuracy is superior. The CTD recommendation results by company are as shown in Table 3, and each company can select TOD comprehensively considering not only technological capabilities but also market conditions. CTS, CTS has TPI 2 is difficult to develop in the short term, but it is useful for exploring long-term convergence directions. The framework can contribute to establishing a practical technology convergence strategy tailored to each company's situations. To verify the practical applicability of the purpose CTOD framework, second cite medical products, which possess both BT-IT convergence capabilities, was set as the target company, and the recommended TC was evaluated through qualitative analysis. First, the companies that process had each recommended CTC were searched, and the technology field and convergence capabilities of the companies were compared with those of target company, thereby verifying the applicability based on technology similarity and market usability. As a result, the purpose framework was empirically proven to be an effective tool for exploring customized technology convergence opportunities for companies. This is the summary and implication of the study. By reflecting the technology convergence capabilities of individual companies, it suggests realistic and feasible technology convergence opportunities. The first TOD study to apply deep learning-based SDAE CF using patent-based corporate technology data. It precisely captures the complex non-linear relationship between companies and technologies. This study greatly contributes to the theoretical and methodological expansion of this field. However, the current model only reflects technological capabilities based on patent data and don't include non-technical factors such as the company size, financial resources, competitive position, and R&D cost. In future study, it is necessary to develop an integrated TOD framework that integrates non-technical variables. Also, due to the time lag between patent application and registration, the accuracy of market competitiveness and growth indicators is somewhat limited. It is necessary to develop supplementary indicators using data other than patents. Lastly, this study is limited to the IT/BT field. It is possible to generalize the model and improve applicability by expanding it to various technological fields such as energy, materials, and environment, and various corporate groups across industries. This is the end of presentation. Thank you for listening.